start with the topic of diagonalizable matrices. This is also interlinked with the topic of eigenvalues and eigenvectors. So the name of the topic is diagonalizable matrices. Diagonalizable matrices are those matrices whose diagonal matrix can be found. जैसे suppose we have n by n square matrix, and this matrix is invertible. Invertible mean its inverse exists. Then square matrix is A, name रख लीजिए. Or if another there exists another n by n invertible matrix P such that P inverse AP is a diagonal matrix. P inverse AP is a diagonal matrix. और diagonal matrix और diagonalizable matrices मतलब जिसका सिर्फ diagonal element नॉन जीरो होता है. जैसे सपोज आइडेंटिटी मैट्रिक्स है तो दिस इज ए डायगोनल मैट्रिक्स जिसका डायगोनल एलिमेंट ही होगा और बाकी सारे एलिमेंट जीरो होंगे. एंड सपोज वी हैव 1 0 0, दिस इज 0 3 0 0 0 4. This is also a diagonal matrix in which diagonal element is non-zero. जैसे 1 है 3 है 4 है. So diagonal element is non-zero. All other elements are zero. So this is also a diagonal matrix. अब diagonal matrix होता कैसे found है? With the help of eigenvalues. So with the help of eigenvalues, we will be able to find out a diagonal matrix. Just see, find out the example is we have a matrix A, and that is 2 1 0 and 0 1 minus 1 0 2 4. This is a square matrix of order 3 in which we have 3 by 3 3 rows and 3 columns. So what we need to have, we have to check whether this matrix is diagonalizable or not. They are asking that is this matrix diagonalizable? This is the question. मतलब क्या इसका ये जो मैट्रिक्स है क्या ये मैट्रिक्स डायगोनलाइजेबल है? This is we need to tell. And before this let us discuss about the matrix which is diagonalizable. And probably ये diagonalizable matrix नहीं है. So let us start with another example about the matrix which is diagonalizable. पहले हम लोग ये एग्जांपल कर लेते हैं फिर हम लोग वो करेंगे. So this is a matrix we have, and this matrix is 2 by 2, and you will be able to find out the characteristic equation A minus lambda I equal to 0. We require this. So this is 1 minus lambda 2 3 2 minus lambda is equal to 0, and we can expand this determinant for finding out the eigenvalues because we require eigenvalues and eigenvectors in this. So we have to solve this equation. This equation comes out to lambda square minus 3 lambda plus 2 minus 6 is 0. So lambda factorize this quadratic equation. So this is a lambda minus 4 is 0. So this matrix has two eigenvalues, minus 1 and 4. Now for these two eigenvalues, we will is x, which is x1, x2 not equal to 0, be the eigenvector corresponding to lambda is equal to -1. Therefore, we can use the equation ax is lambda x, and this is ax is equal to minus x. This can be written a plus lambda I into x is 0. Now you can find out from this, and the matrix A is 1. This is 1 over 2, 2, and this is 3, and this is 3. And x is x1, x2 is equal to 0, 0. And we know that we will be able to find out one equation from this. 2x1 plus 2x2 is 0. 3x1 plus 3x2 is 0. Both equations are same because from this equation x1 plus x2 is 0. 2 can be taken common and cancel with the other side. 3 can also be taken common. So that is why both the equations are same. x1 plus x2 is equal to 0. So इन दोनों इक्वेशन में से एक ही इक्वेशन निकल करके आ रहा है, and from this we can find out x2 is equal to minus x1, and we will be able to find out the eigenvector. So x1 over 1 and x2 is minus 1. So therefore the eigenvector is x, that is 1 minus 1. So this is the eigenvector corresponding to lambda is equal to minus 1. Similarly, for the other eigenvalue lambda is equal to 4. Let we have another eigenvector x, that is y1, y2 not equal to 0. So therefore ax is equal to lambda x gives ax is equal to 4x. So it is a minus 4i into x is 0 vector. And with the help of this, you will have the equation. You will have the matrix form -3, 2, 3, -2. X is y1, y2 is equal to 0, 0. And you will have a single equation from this. -3y1 plus 2y2 is equal to 0. So y1 will be 2 by 3 y2. Or therefore, what we should have uh, y1 upon 2 and y2 upon 3. And what does it mean? This is the eigenvector we have. So x is equal to 2, 3. And this is the eigenvector of A corresponding to lambda is equal to 4. So दो eigenvector आ गए 1 minus 1 and 2, 3. And ये जो eigenvector होते हैं ये हमें invertible matrix P देते हैं. P matrix कौन सा? This is known as model matrix. P का जो नाम है that is model matrix which is invertible. Invertible है. Invertible means जिसका inverse exist करता है. इसको हमने ऊपर definition में भी बताया. And top पर चले जाइए, ये वाला. Such that P inverse AB is a diagonal matrix. So this is an invertible P matrix. So P is there. So let us use this P. And how to find out P? First eigenvector. First eigenvector will be written as a first column. Second eigenvector will be written as a second column. So this is a 1 minus 1 and this is a 2, 3. This is your P. Now you can find out P inverse. You know that P inverse will be 1 over P determinant adjoint of P. This is the method for finding out inverse. P determinant is 5, 3 plus 2. So now let us find out adjoint. Adjoint of P by you finding out the cofactors. And the first we will expand by 1. 1 से expand करेंगे तो जो cofactors हैं वो हमारे पास आ जाते हैं 3 and 1. और दूसरे आ जाते हैं -2 and 1 ट्रांसपोज. So this is 3 1 -2 1. So put the value here 1/5, that is 3 1 -2 1. This is your inverse P inverse. Now let us find out P inverse AP, because P inverse AP will give you, yeah, will give us a diagonal matrix. P inverse AP will give us a diagonal matrix. This is the technique or formula to find out diagonal matrix. What is P inverse? 1/5, 3 -2, 1 1. What is A matrix? A matrix was given to us, that is 1 2 3 2. And what is P? P is this one, 1 2 -1 3. Now let us multiply these three matrices one by one. So first of all, multiply this matrix with this. 3 is to 1 is 3, and -2 into 3 is 6. So -3. 3 into 2 is 6, and that is -4, that is 2. And 1 into 1 is 1 plus 3, that is 4. And this is 1 into 2, 1 into 2, that is also 4. 1 2 -1 3 is there. Now let us multiply these two. -3 into 1 is -3, and -2 -5. And -3 into 2 is 6. 2 into 3 is 6, that is 0. 4 into 1 is 4. 4 into -1 is 4, 0. 4 twos are 8. 4 threes are 12. And this come out to be 20. So divide it by 5. 5 will be taken inside. -1 0 0 4. So this is the diagonal matrix. It is clear. Only diagonal elements are there. Remaining elements are 0. So which is a diagonal matrix. ये एक डायगोनल मैट्रिक्स हमारे पास आ जाता है. तो इसका मतलब जो गिवन मैट्रिक्स ए था उसका डायगोनल मैट्रिक्स एग्जिस्ट करता है, वो डायगोनलाइजेबल है. So we can say that the given matrix A in this question is diagonalizable. और एक और इंपॉर्टेंट बात है, डायगोनल में कौन से एलिमेंट आएंगे? ईगन वैल्यूज. जस्ट सी द ईगन वैल्यूज ऑफ ए. ईगन वैल्यूज ऑफ ए was -1 and 4. Just see, lambda is -1 and 4. These elements will always come as a diagonal element. -1 4. ये हमारा एक तरह से चेक है कि whether our question is correct or not. आइगन वैल्यूज हमेशा उसके डायगोनल में आएंगी जब भी हम लोग ये वाला टेक्निक यूज करें. नाउ ये क्वेश्चन में मैट्रिक्स ए वाज डायगोनलाइजेबल, but let us do the earlier question which we have mentioned here. This one, you have to check that this matrix is diagonalizable or not. यहाँ पर हमारा लिटिल डिफरेंट टेक्निक यूज होएगा. सो a माइनस लैम्डा i 2 minus lambda 1 0 0 1 minus lambda -1 0 2 4 minus lambda is equal to 0. Now you can expand the determinant. So let us expand the determinant, that is 2 minus lambda into 1 minus lambda into 4 minus lambda, and this is plus 2. और रिमेनिंग -1 से करेंगे तो 0 इंटू दिस एंड 0 इंटू दिस, वो 0 आ जाएगा. अगर 0 से करेंगे तो वो 0 आएगा. तो बाकी दोनों में वो 0 ही आएगा. सो 2 minus lambda is there, and this is 4 minus 5 lambda plus lambda square plus 2. So what we should have? It is clear, one eigenvalue, and this is 2 minus lambda, and this is a lambda square minus 5 lambda plus 6. और यहाँ से देखें तो यहाँ से देखें तो हमारे पास, बिकॉज हमने क्या करना था, ये देखिए a माइनस लैम्डा आई डिटर्मिनेंट इज इक्वल टू 0 है, एंड दिस शुड बी 0 से हमारे पास लैम्डा इज इक्वल टू 2, एक फैक्टर यहाँ से आ जाता है, और यहाँ से फैक्टराइज करके हमारे पास क्या आता है, लैम्डा स्क्वायर माइनस 2 लैम्डा माइनस 3 लैम्डा प्लस 6. सो आई थिंक दो और रूट आ जाते हैं, 2 और 3. यू कैन चेक. सो दीज आर द आइगन वैल्यूज ऑफ गिवन मैट्रिक्स ए. अब ये देखिए दोनों सिमिलर आइगन वैल्यूज आ गई हैं. यहाँ पर थोड़ा डिफरेंट लगेगा. और लैम्डा इज इक्वल टू 2, so let the eigenvector is x1 x2 x3. Eigenvector always be a column matrix, and this is corresponding to lambda is equal to 2. So therefore ax is equal to lambda x gives ax is equal to 2x, and this will be a minus 2I into x is equal to 0. So use here ax is equal to 2x is there, so put the value of a and 2I, and it will give you, this is 0 1 0 0 minus 1 minus 1 0 2 2, and the x vector is x1 x2 x3, and zero vector or null vector is 0 0 0. This is again a column. So let us use, and the third row can be made 0. It is clear. और सिंपल मल्टीप्लाई करके भी कर सकते हैं. अब देखिए फर्स्ट से हमारे पास क्या आ रहा है. अब फर्स्ट जो रो को जब फर्स्ट इससे मल्टीप्लाई करेंगे तो आ जाएगा x2 इज इक्वल टू 0, और थर्ड रो से आएगा माइनस x2 माइनस x3 इज इक्वल टू 0, और लास्ट रो से भी यही आएगा 2x2 प्लस 2x3 इज इक्वल टू 0. अब ये दोनों सेम है, यू कैन सी सिमिलर है, और पहली इक्वेशन से तो क्लियर है x2 का वैल्यू 0, और जब आप x2 0 इसमें भरेंगे तो x3 भी 0 आ जाएगा. सो यू विल गेट दैट x2 is 0, x3 is 0, and you are not able to find out x here, x1 here. So you have to take the value of x1, then that will be assumed value. So assume x1 is equal to 1 always. जब भी कभी ऐसा केस हो तो आपने, जब आपके दोनों ही रिमेनिंग एलिमेंट 0 आ रहे हैं, तो ऑलवेज अज्यूम द अदर एलिमेंट एज नॉन जीरो. क्यों? बिकॉज हम मान करके चलते हैं कि ये एक नॉन जीरो वेक्टर है. तो अगर दो एलिमेंट 0 आ गए और तीसरा भी 0 ले लिए तो वो 0 वेक्टर बन जाएगा. So that is why we need to suppose the other element as non-zero. वो हम लोग 1 ले सकते हैं. और ये this is eigen vector, is eigen vector of A corresponding to lambda is equal to 2. And अब देखिए एक और बात इसमें जो इम्पोर्टेंट है, जब हमारे पास एक आइगन वैल्यू 2 बार आ गया है, इसका मतलब इसके दो केसेस अलग अलग नहीं हो सकते. अब ये जो वेक्टर है ये तो सेम ही रहेगा. सो सेम आइगन वेक्टर वी आर गेटिंग फॉर सेम आइगन वैल्यू. इट मीन ये दोनों कॉलम बनाएगा 1 0 0 1 0 0. और फॉर लैम्डा इज इक्वल टू 3 लेट अस डू द प्रोसीजर. और लैम्डा इज इक्वल टू 3 के लिए हम लोग उसको सॉल्व करते हैं. तो लेट अस सॉल्व फॉर लैम्डा इज इक्वल टू 3. solve for lambda is equal to 3 here, or lambda is equal to 3, let the eigenvector is y1, y2, y3, which should be non-zero vector, and use the equation ax is equal to lambda x will gives ax is equal to 3x. So a minus 3I into x will be null vector. So put the values of a and 3I, you will get minus 1, 1, 0, 0, minus 2, minus 1, 0, 2, 1 into y1, y2, y3 is equal to null vector, 0 column vector. So this can be, the third row can be made 0 by operating the operation, operating R3 as R3 plus R2. You can do that. R3 as R3 plus R2 will give you minus 1, 1, 0, 0, minus 2, minus 1. That will be 0, 0, 0. This is y1, y2, y3 is equal to 0, 0, and 0. Now multiply inside, that is minus y1 plus y2 is 0. And from the second row, you will get minus 2y2 minus y3 is 0. From first equation, y1 is equal to y2. And from this equation, y2 is equal to y3 upon 2. This will be upon 1. So this is proportional to 1. This is proportional to 1. So combining this and this, we should have y1 upon 1, y2 upon 1, and सॉरी दिस शुड बी -2 बिकॉज जब हम माइनस को उधर ले जाएंगे वो प्लस बन जाएगा और ये -2 वहां लगेगा. So y3 upon -2. All these ratios are same. So these are same ratios by taking as equivalent. So it will give you the eigenvector, and the eigenvector is thus the eigenvector is y1, y2, y3, that is 1, 1, minus 2 is the eigenvector of A for lambda is equal to 3. So एक ये eigenvector हो गया, एक हमारे पास ये eigenvector है 1, 0, 0 and 1, 1, minus 2. So by combining these two, we should have a model matrix, and the model matrix will be first vector will be first column, second vector will be second column, third vector will be 1, 1, minus 2. Now the question arises, is this matrix is invertible or not? This is important because we have to use the formula of P inverse AP. So you have to use this technique, that P inverse AP. We have to use this formula. So for finding out P inverse, we should be able to know the value of P determinant. And clearly P determinant is 1 into 0 minus 0 minus 1 into 0 minus 0 and plus 1 into 0 minus 0. So P determinant comes out to be 0. Therefore P is singular matrix, and if a matrix is singular, therefore P inverse does not exist. तो P inverse exist ही नहीं करता है, तो P inverse exist नहीं करता है तो P inverse AP भी फिर exist नहीं करेगा. So we can say that, therefore we can say that the given matrix A is not diagonalizable. Given matrix A is not diagonalizable. इसका मतलब है जो given matrix है वो diagonalizable नहीं है. And यहाँ पर हमने जो यूज करा है पी इनवर्स वाला, जिससे हमने बता दिया कि ये डायगोनलाइजेबल नहीं है। हम सीधा भी बता सकते थे, जब हमारे पास दो मैट्रिसेस आ जाते हैं, दो वेक्टर आ गए हैं हमारे पास, 1 0 0 एंड 1 0 0, एंड क्लियरली these two vectors are linearly independent vectors. तो जब भी हमारे पास लीनियरली इंडिपेंडेंट वेक्टर्स होंगे तो तब भी हम लोग मैट्रिक्स ए को डायगोनलाइज नहीं कर पाएंगे। तो रिमेंबर दैट these two vectors are linearly independent, and this is one of the other reason that the matrix A is not diagonalizable. ये इनवर्स वाला भी रीजन है कि डिटरमिनेंट सिंगुलर मैट्रिक्स देता है तो P inverse does not exist. So you can explain that the given matrix is not diagonalizable. So thank you very much. I stop my lecture here. Thank you. You can ask me your queries.